Okay, in this lab we're going to get the respiration rate of crickets in room temperature and in the cold. So here are our crickets. What we want to do then is take 5 of these crickets and place them into this container and then use this container for getting the respiration rate. Now if you look at the crickets, they're all different sizes. And so 5 crickets then would have a different mass. Typically in science then you want to replicate your experiments. And so when you replicate your experiments, in order to analyze your data, you need to have each replicate on the same scale. So we could do 5 crickets as our scale and divide everything by 5 and go per cricket. But since 5 crickets weigh different, have a different mass, it would be more appropriate then to actually mass the crickets, divide by the mass of the crickets and go per gram, which would be much more accurate in moving on. So what I want to do is get the mass of the crickets. So to begin with, we're going to get the mass of this container. So you can go ahead and write down that value for the container. Now I'm going to take the container over here. We will put on the funnel right there. And I'm going to grab the crickets. And I'm going to put 5 crickets inside this container. 1, 2, 3, 4, 5. Oh, that was close. All right, so then we're going to put our 5 crickets into that container there. And now we will put the crickets back on the balance and zoom in so you can write down that value. So the next step then is to measure the respiration rate. In order to measure the respiration rate, we are going to need to measure the output of carbon dioxide. Okay, so respiration then is a process which gives out carbon dioxide. That carbon dioxide then can be measured by a carbon dioxide probe, which is going to measure the parts per million of carbon dioxide in the atmosphere. So I'm going to take this probe, put it into the chamber here. Okay, we'll make sure that it just stands up there. Now if you look in the background then we can see that the probe is hooked up to a computer and the computer is hooked up to software ready to run this lab. So now that we have the crickets in the chamber, we've been letting the crickets sit at room temperature for a little while. We're actually going to go in and take a reading. And so if you look here, here is a graph. Okay, we have our y-axis being CO2 parts per million. So we're going to be looking at CO2. Here's a live reading of CO2. We have about 454 in the chamber right now. Down here, our x-axis is minutes. So I'm going to click play up here. And I'm going to allow that to get started then. Okay, here's our line. If our crickets are going through respiration, should we have an increase in CO2 or a decrease in CO2? So respiration puts out CO2, and so we should be able to see an increase, and so that line is moving up like it should be moving up in here. Okay. And so now I'm just going to leave that running for 5 minutes. And then we will come back in 5 minutes. Okay, so I've just completed running this for 5 minutes. I just turned it off up here. And so we have a nice, steady, straight line trend of respiration increasing from this point to this point in CO2. So the next step is to go ahead and analyze these data. So what I want to get is a respiration rate, which is basically change in CO2 parts per million per minute. In order to get that, then what I really want is the slope of this line. So I'm going to highlight this line right here. Then I'm going to go over here to this tool, which is the best fit line tool. Right there, linear fit. Click on that linear fit. And this then is going to give me information on the best fit line. We'll go ahead and zoom in so that you guys can go ahead and read that information on the best fit line. Okay, and get the slope. Okay, now that we have our reading for crickets at room temperature, we'll look at the thermometer, and we can see that it is 20 degrees centigrade. Okay. Here is the crickets. We now want to cool them off, so we can put them on ice. So wrap this around, get them all in there. And we're going to give this 5 minutes to wait. Then in 5 minutes we'll add the CO2 probe to it, and we'll go ahead and start it on the computer again. Okay, now we are ready to do our next trial. So I'll go here, I'll click that off. The crickets have been under here for 5 minutes, and so now they're nice and cool. So I'm going to go up here, click play, start. Now I'm going to store the latest run so we can see both of these together, and they'll be both on the same scale. And there we go. So we started just about at the same level of CO2, which is good. You can see that so far that line is starting, and the line has a lower slope than the other line. If it continues that way, we'll see. We're going to run this over the course of 5 minutes. Okay, so now we're about finished here. We're at 4.9, one more tick, and there's 5 minutes. I'm going to click stop on here. As we did before, then I'm going to go over here and we can look at our slopes, right? So this slope is a lot lower than this slope. So since this slope is lower, it looks like our respiration rate of our crickets in cold is slower than our respiration rate of crickets in warm. Ultimately, then we're going to run statistics to see how we want to evaluate this. So I'm going to highlight that. We'll click again on the best fit line. I really only want the latest run because I already got the best fit line for the earlier run. Grab that, and then I'll move that right next to that one. Okay. And then we'll go ahead and zoom in as far as we can. And I'll move both of these down just a teeny bit so that you can then see that slope on there. And we should also just make a quick observation of what's happening to our crickets. And so we can open this up, right? Take our crickets off, and we can look at our crickets here. So our crickets aren't moving very much at all. They're pretty much kind of there. They're not really dead, they're just in a torpor. And so, yeah, it's kind of important to realize, though, that this isn't really cruel to the crickets, because these crickets are different than people. So think about our hypothesis and think about what's going on physiologically with this guy that allows them to be put on ice and to cool down like this, and how that would be different than people. Now, temperature-wise, I just checked the temperature a few minutes ago, and our temperature in here was down to about 9 degrees. So temperature is 9 degrees C. At the beginning, it was 20 degrees C. And just to show you that no crickets were harmed in this study, we let it sit about 5 minutes here and let them warmed up, and our crickets are all back up moving around like they were before. So back to normal. Okay, so here we have all of the student data on the board. We have 5 groups, or 6 groups, group A, B, C, D, E, and F. You guys can consider yourself group F. Okay, so that group that's really slow, last ones in the class to add their data, that's you guys. So you can add your data to this table, transfer it to an Excel spreadsheet, and do your statistics.